A manufacturer of CD players has determined that the profit, P of X, in thousands of dollars, is related to the quantity X of CD players in hundreds per month by P of X equals the quantity X minus 4 times e to the X minus 4, and this is valid for X values greater than 0 but less than or equal to 3.9. At what production levels in that interval is the profit increasing? So we're going to be looking for critical numbers from 0 to 3.9. If we get anything outside of that, we're just going to ignore them because for this problem, those are irrelevant. We'll take the derivative, and I've done all the steps here for you. Remember, we need to take the derivative of this first piece, which is going to require a product rule. The derivative of negative 4, well, that's going to be 0. So if u is x minus 4 and v is e to the x, we have v, which is e to the x, u prime, the derivative of x minus 4 is 1, plus u, v prime, the u, remember, was x minus 4, and the derivative of e to the x is e to the x. Now that I've done that product rule, we can go ahead and try and combine some of these terms together. The way I'm going to do that is I'm going to go ahead and distribute the e to the x onto the x minus 4. That gives me e to the x plus x e to the x minus 4 e to the x. E to the x minus 4 e to the x is minus 3 e to the x. And now that I've combined my terms together, I see a common e to the x. When I factor it out, I get the quantity x minus 3 times e to the x. In this last step, it's real critical that we go ahead and factor, because once we have something factored, it's a lot easier to see where the product is equal to 0, because then we can look at the individual factors. In this case, we're going to look at where x minus 3 is equal to 0 or where e to the x is equal to 0. Our problem, though, is it's easy to see where x minus 3 is equal to 0. That's got to be at 3. But what about e to the x? Well, if we look at a graph of e to the x, it looks something like that. It never crosses the x-axis. It actually has a horizontal asymptote there. That means that e to the x is never equal to 0. So we can ignore the e to the x and concentrate on where x minus 3 is equal to 0, which means where x is equal to 3. E to the x is never equal to 0, so we're just going to ignore it from here on out. Our only critical number is at x equals 3, and that's what we're going to put on our number line. So I've gone ahead and labeled the 3 on here, and we don't have to look anywhere beyond 0, because remember, this problem went from 0 up to 3.9. Even though 3.9 is our cutoff, we can still test things farther out to the right here. That's really not a problem. So let's go ahead and test and see what we get. So if we test at 0, when I plug 0 into these factors, I get 0 minus 3, which is negative. E to the 0 is 1, so it's positive. So negative times positive gives me negative on my number line. Now I'm going to go ahead and pick 5. Remember, even though that's beyond 3.9, since this is a continuous function, we can test anywhere out here to the right. When I go ahead and plug that in, I get 5 minus 3, which is positive, e to the 5th, which is also positive. Positive times positive gives us positive, so we'll go ahead and label a positive on our number line. The problem here asked us, where is our profit increasing? And remember, our profit was increasing where the derivative is positive, so from 3 to the right, and remember, everything here ends at 3.9, so in effect, we should be looking from 3 to 3.9. Now, the function itself is actually going to be positive all the way to infinity. So if we were just looking at this as purely a problem where it was a formula not connected to this application, we'd say 3 to the infinity. But in this case, since we're dealing with something that cuts this off at 3.9, we're going to say from 3 to 3.9, and we're going to include that 3.9 because that's a possible production value.